All right, so we know that decimals that terminate or end are rational numbers because they can be converted into their fraction or ratio equivalents. You can also do that for decimals that repeat forever. So if the decimal doesn't terminate, if it does repeat, then it is still rational. It's just a little bit more difficult to turn it into a fraction, which is why I saved it for a video entirely for itself right now. So let's say 0.666666, it goes on forever. So it does repeat, but it also goes on forever. But we know that it's a rational number. Now let's convert it into a ratio. It's tougher to convert it into a ratio because remember before, if it was 0.6, which terminates, I could say, oh, that's 6/10. So I could just do 6 over 10, which is a rational number. If I wanted to reduce it, I could. So 2 goes into 6 3 times, 2 goes into 10 5 times, voila. 0.6 is equivalent to 3/5, okay? Harder to do that with this since it goes on forever. You don't know what to put in the denominator. It would be like writing 6's in the numerator indefinitely, and then a 1 with an infinite number of zeros in the denominator. That's no way to make a fraction because you're never going to be ending on a place where you can cut the fraction off. So how do you turn this into a decimal? Here we go. We have this number and it goes on forever. We're just going to call it x. We're going to say all of this is equal to x. Just a variable that we made up. You could say x, you could say a, you could say z. It doesn't matter. We're just setting it equal to something that we make up, okay? Now, what I'm going to do here is I'm going to multiply this side by the same number that I'm going to multiply this side by. Because you can always, in an equation, do one thing to one side as long as you do the exact same thing to the other side to make sure that it still balances out. So if I wanted to add 5 to this side, I'd have to add 5 to this side to even it out, okay? If I divided this side by 1,000, I'd have to divide this side by 1,000. What we're going to do is we're going to multiply this side by 10 and this side by 10, okay? So if I multiply this side by 10, what happens? Well, remember, when you multiply by 10, you move the decimal point one place to the right. So if I multiply this by 10, I would get 6.6666 on forever. You see that? So I multiply this by 10, so I'd move this over. So it's 6.666. So here it's 6.6, okay? And then over here, I multiply this side by 10, so I need to multiply this side by 10. So 10 times x is 10x, okay? So now I have created 2 equations. What I'm going to do now is, remember, since this equation is a valid equation and this equation is a valid equation, I can subtract the bottom equation from the top equation. That is going to be very helpful because do you see all these 6's line up forever? So that means they will cancel each other out forever. And 6 minus 0 is just 6. And then over here, 10x subtracting 1x is 9x. So now do you see that we've come up with an equation where we don't have any decimals, let alone repeating decimals? So now let me just solve for x. If this is 9 times x over here, how do you isolate x? You divide both sides by the coefficient, which happens to be 9 here. And so any number over itself is 1. 9 over 9 is just 1. So you're left with 1x, or just x. So x equals 6/9, just like that. If you wanted to reduce that, 3 goes into 6 and 9. So 3 goes into 6 twice. 3 goes into 9 3 times. So what we have is 2/3. So it turns out by the way, since x equals 0.666666 and x also equals 2/3, we should be able to logically conclude that x equals 2/3. We have just converted this repeating decimal into its fraction equivalent. And do you see that in the numerator and denominator, we have two integers? That's the definition of a rational number. So 0.666 repeating forever equals 2/3. If you wanted to prove it another way, you could divide 3 back into 2, and you would get, if you divided 3 into 2, 3 goes into 2 0 times. 0 times 3 is 0. Bring down this 0. 3 goes into 20 6 times. 6 times 3 is 18. 20 minus 18 is 2. Drop down another 0, so you get 20 again. 3 goes into 20 6 times. Do you see how I'm just going to repeat this over and over again? So I've proven it several ways that 0.666 repeating is the equivalent of 2/3. Thus, fractions, even if they go on forever, if they do repeat, they are still rational numbers.